Hello, Algebra 2 Trig students. This is Mr. Morris. Today we're going to learn how to solve linear systems algebraically. Now, this first example says solve the system using substitution. The key to this problem is finding one of the equations, the top or the bottom, and deciding which one's easiest to solve for x or y. Now, in this case, the top equation has a variable with a 1 in front of it. So I have a 1x here, which means this is going to be the easiest equation to solve for one of the variables, and I will solve for x because of the 1 in front. So I'm going to rewrite this over to the right as x plus 2y equals 12, and I want to get x by itself. And so I'll subtract the 2y, and that will leave me with x equals 12 minus 2y. Now that I have x equals 12 minus 2y by itself, I am going to go ahead and substitute in this x for this x in the other equation. So I'm going to take 9 times, and I'm going to put this in blue. And what I'm really doing is replacing x with its equivalent, 12 minus 2y. So this x is now going to become 12 minus 2y because it's equal to x. Now I'll bring the rest of the equation down, minus 5y equals negative 30. So you can see in blue, the only thing that changed was the x became 12 minus 2y, where I substituted in x equals 12 minus 2y, where 12 minus 2y replaced the x. Now from here, I only have y's left in this equation, which means I can solve this for y, which is really the goal, to get rid of one of the variables by substitution. So I'm going to distribute this 9 times 12, and if you need your calculator, that's fine. It's 108. Distribute 9 times negative 2y is negative 18y. And then this just drops down, minus 5y equals negative 30. And I solve this equation for y. So on this side, I'm going to combine like terms. Now be careful. I've seen many students make the mistake of accidentally switching one of these signs. When you're on the same side of the equal sign, you are combining like terms. So this is 108 minus 23y equals negative 30. So I just combine the like terms. The negative 18y minus 5y is negative 23y. I will subtract 108 from both sides. Now you got to be careful. There's a negative right here, which a lot of people lose track of. So I have negative 23y equals negative 138. You really got to watch your signs here so you don't make a silly mistake in the middle of this problem. Lastly, to solve for y, I will divide by negative 23. So, if you need your calculator again, divide by negative 23, you will get 6. Now, this problem isn't over. What I'm really looking for is a solution to a system of equations when both the x and the y substituted into both equations make both equations true. Or if I were to graph both of these, they would be the equations of a line, and I want to find their intersection point. So now what's nice about this is I have y equals 6, and I have an equation right here where I can substitute 6 in for this y and find x. So I'll just move this over here, and I will take x equals 12 minus 2 times that 6, and now I can solve for x. So x is going to be equal to 12 minus 12, and so x is 0. Now don't worry, 0 can be a solution to either your x or your y. As a matter of fact, you can get both x and y be 0, and that means the answer is just simply at the origin. And so we always write this final answer. We have this x and this y as an ordered pair, where x is 0 and y is 6. So this problem is done. And again, if you were to graph this equation right here, and you were to graph this equation right here, they are lines. The point at which they would intersect would be at 0, 6. Okay, now example 2 has different directions. It says solve the system using elimination. You have to follow directions. So if we ask you to solve by a certain method, you must use that method. Now this one's a little different, but the goal in the very end is the same, is to find the intersection of these two lines. All right, if it exists, and we'll talk about that more in class. Now, when we solve by elimination, I want to try to add these two equations together, and the goal is to get coefficients in either the x or the y to cancel. Now to do that, I need the numbers to have the same value but opposite signs. For instance, if I add a 10 plus a negative 10, I get 0. All right, so in this problem, again, you have to make some choices. I want to decide which of these equations that I have to actually multiply a number by the entire equation to create opposites. And so if I look at the top equation, I've got 2x minus 4y equals 13. The bottom I have 4x minus 5y equals 8. And if I were to multiply the top equation by negative 2, I would have a negative 4x. And if I added that to 4x, then I would get 0. And so on this kind of problem, you want to think ahead and decide what to do really before you actually get going on the problem. So you want to have a plan on how to solve it or eliminate what variable. So I'm going to multiply this by negative 2. And if I do that to the left side, I also have to multiply the right side by negative 2. Now I'm going to write that result over here. And you have to just be careful with your sign and distribute the negative 2. So negative 2 times this 2x, so I'm distributing negative 2 times 2x is negative 4x. And then I also multiply negative 2 times negative 4y, which is positive 8y. And on this side, don't forget, I have to multiply both sides, a very common mistake. Negative 2 times 13 equals negative 26. Now, I'm just going to take this equation and rewrite it. I don't have to do anything to it in this problem. So I'm going to just rewrite 4x minus 5y equals 8. Now, there will be problems in which you have to multiply the top equation and the bottom equation by numbers to create opposites. Here we didn't have to. And so 4x plus a negative 4x. And I'm going to put a plus out here. Really, when I solve by elimination, I always do it by addition because it's easier to keep track of your signs this way. And so we're adding these two equations together. So negative 4x plus 4x is 0x, and I don't have to write that, so they drop out. 8y plus minus 5y is 3y. Negative 26 plus 8 is negative 18. Be careful with your signs when you're doing these problems. You're welcome to use your calculator. Now, I'm going to solve for y by dividing by 3. And so y equals negative 6. All right, now, just like the last problem I did in example 1, I have half of my solution. I have y equals negative 6, and I need to find what x is. Now I can go back to either of my two original equations and plug y in and find out what x is. All right. Now, even though this part is solving the last variable, x, by substitution, the whole process is really called elimination. So here at the end, it's okay to substitute. All right. So I've got this y right here, and I'm going to replace it with my negative 6. So I have 4x minus 5 times negative 6 equals 8. So 4x. Now here it's negative 5 times negative 6. So plus 30 equals 8. And when I subtract 30 here, subtract 30 from both sides, 4x will equal negative 22. Again, be very careful with your signs and use your calculators if you need to. Divide by 4, divide by 4. So now x is going to equal, I will reduce this negative 22 over 4. 2 goes into negative 22, and that will be negative 11. 2 also goes into 4, so that will be 2. Now, a lot of students say, oh my goodness, this cannot be an answer. I got a fraction. Well, this is the answer. You can get a fraction. And so I'm going to rewrite the ordered pair here over to the side, where we always write it x first, and then we'll write our y. Okay, now if you're ever concerned whether this solution actually works, all you have to do, and I'm not going to do it here, but all you have to do is plug your x in for x and your y in for y and make sure that this statement is true. Now, the key though is you would have to do it for both equations. So if you want to check your solutions, you plug the ordered pair in, one for x and the other one in for y, and see if you get a true statement, but you have to check both equations. Now, for these problems that say your turn, what I'd like everyone to do is go ahead and try these after I'm done with the video, and we'll go over and talk about them in class tomorrow. I'm going to have time to do just one of these word problems. So I'll do this top word problem. All right, your family is planning a 7-day trip to Florida. You estimate that it will cost $270 per day in Tampa and $400 per day in Florida. Your total budget for the 7 days is $2,300. How many days would you spend in each location? Now, I'm going to let my variables be known here. So I'm going to set t equal to days Tampa. And now I don't want to use O for Orlando because it'll be really confusing. It'll look like a 0. So I'll let R equal days Orlando. Okay, now I'm going to use those variables to write a system of equations, and then we need to solve the system of equations. Now, I've got information here that tells me your family is planning a 7-day trip. All right. Well, that usually is your first equation you want to write. It's the easiest equation, which means I know that I have T for days in Tampa plus R for days in Orlando, and that's going to equal a total of 7 days. Usually one of your equations is real easy to write like that. All right. The other equation that I'm going to write has to do with the amount of money. You estimate that it will cost $275 per day in Tampa. That means it's going to be $275 per day in Tampa, plus $400 per day in Orlando. So plus 400 days in Orlando times the number of days. That'll give me an amount of money. My total budget is $2,300. All right, now, one thing to make sure we understand is how these variables go together. All right, I said this before, but just to make sure we're clear. Up here I have an equation that's just days. This is days Tampa plus days Orlando is total amount of days. Now, in this equation down here, it's all about money. I have $275 per day times days, which gives me amount of money, plus $400 per day times the amount of days, which also gives me money, added together equals an amount of money. So make sure when you set up your equations that you're adding like terms that make sense. Now, I'm not going to have time to solve this right now. We can talk about it briefly, and then we'll finish it in class the next time we meet. Now, I could solve this equation either by substitution or elimination, and we can discuss in class the easiest way to do this problem. All right, have a nice evening.